Let's take a look at your MT4, LT4 seminar. Uh, Before you begin, do the first 5 questions. We'll go over those in class, so make sure you get those done and hang on to your seminar sheet. And what we're going to be looking at today is applying transformations to linear functions. And by transformations, I mean translations, slides, dilations, which means shrinking or stretching, and reflections. A family of graphs starts with a parent function. See the kind of vocabulary we use? The parent function is the simplest form of the function we can have. That is, no numbers, just variables, or at least the very least numbers. We're going to start today by looking at our identity function, which is f of x equals x, the most simple linear function there is. Remember, that's y equals x, because that's what f of x is. So it's going to be a perfect diagonal line. Notice your slope is 1, your y-intercept is 0. That's the parent function. Now, as we add numbers onto that, that's going to be your transformation. We're going to look at, hey, where we put those numbers changes how we do the graph. We're going to look at those through some viewpoints here. Let's go to the next page here. Now, our first function we're going to look at is a vertical translation. That is, it slides up and down. If I add a number on to my parent function, it slides it up or down. If the number is positive, it slides it up. If it's negative, it slides it down. You can see that by looking at my Desmos line. Notice I've got f of x equals x. That's my orange line, which I covered up with the blue line. And what I'm going to do is I'm going to add something on to my function. And you can see, well, if I could get this, as I add that on, it moves it up and down. Now, it should kind of make sense because you're just changing the y-intercept, aren't you? So if you add something on to your function, it just puts it up and down. So if we take a look, get back here because I went out. Let's do a problem. So if I've got g of x minus 2, what happens to the function? Well, it moves it up, or in this case, down 2. So my graph slides or translates down 2 from the center. Now, if you do something inside the parentheses, that is, rather than add it on to the entire function, I'm going to do something to x first. That's going to be a horizontal translation, and it's going to slide it left and right. Now notice, if it's x minus h, it slides it to the right. If it's x plus h, it slides it to the left. Why is that? Well, you got to think. If I've got x minus h equals 0, what do I do to get x by itself? Well, I'd add h to both sides, wouldn't I? That's why you slide it to the right. And we can look at a translation here. I'm going to hide that one. And let me add. Notice I'm going f of x minus h. So when I move x to the right, make it x minus, like minus 1.2, notice it changes my x-intercept, not my y-intercept. My x-intercept changes. Notice the y-intercept changes too, so it's kind of confusing, but that's what we're looking at. We're looking at this x-intercept. Notice x minus 2.3. And so we move the x-intercept if you do something to x first, and then it's backwards. So yes, you have to memorize that. So if I look, Get back here. So if I look at another example here, I'll do that in the next video actually.